explain the following terms. First, governing equation of force damped vibration. Second, graphical solution of force damped vibration. Third, magnification factor or dynamic magnifier.
Let us understand the concept of force damped vibration with the help of diagram. The system consists of spring with stiffness K, mass M and damper with damping coefficient C. Now this system is applied with external periodic force which contains the frequency omega. Now this external periodic force is having harmonic excitation, and we know that this harmonic excitation follows the sinusoidal wave. So this external force which is applied to the system is known as Fo sin omega t. Now when we apply this external force to the system vibrates about its mean position. Now for this diagram, displacement x is shown in the downward direction, and we have to draw the free body diagram. So when the displacement x is in the downward direction, that means this external force Fo sin omega t will also act in the downward direction. So for free body diagram, we will show here Fo sin omega t is in the downward direction, x displacement is also in the downward direction. Now when this system moves or displaced from its mean position to the downward direction, then the elements mass, then spring with stiffness K and damper will try to bring the system back to its original position, and that's why the inertia force is getting applied. So we will write here the inertia force that are getting applied because of the elements mass, spring and damper. So inertia force due to mass is known as m into x double dot, and which will act in the opposite direction to the displacement. So we will show here m into x double dot. Now spring force which will also act in the upward direction. So spring force is known as kx and damper force is known as c into x dot. So this is the free body diagram, and we have to show here the mass m. Now we will find out the equation of force damped vibration. Now here word damped is used because in the system damper with damping coefficient C is provided. So this is known as force damped vibration. We will apply here D'Alembert principle for this free body diagram. So D'Alembert's principle is summation of inertia forces plus external force is equal to 0. Now inertia forces are in the upward direction and the external force is in the opposite direction, that is downward direction. So if we give here for upward direction positive sign, then for downward direction we have to give here the negative sign. So we will write here mx double dot plus cx dot plus kx minus Fo sin omega t is equal to 0. Now if we simplify this, then we will get mx double dot plus cx dot plus kx is equal to Fo sin omega t. And this is the governing equation of force damped vibration. Now again we know that what is the meaning of x double dot. So here this x, that is the displacement x, is the function of time t. So we can write here x double dot as a d square x by dt square. Then x dot we will write as a dx by dt. So how we can rewrite this equation? We will write here m d square x by dt square plus c dx by dt plus kx is equal to. Now here for Fo sin omega t we will write Rx, and this is the, we will give here this equation as equation number 1. Now this equation is known as the linear and non-homogeneous equation because on the right hand side there is the term Rx. This equation is having two types of solution. First is complementary function xc and second is particular integral xp. Now we will assume the underdamped system and we will write xc is equal to capital X e raised to minus omega n zeta t sine of omega dt plus phi. Now when we observe it's a graph, then the amplitude diminishes with respect to time. So this type of vibration is known as transient vibration. So with time t, this complementary function is negligible. And when we put t is equal to infinity in this value, that is e raised to minus infinity is equal to 0. So this complementary function xc is negligible with respect to time t. Now when we move to the second solution xp, then it is capital X sine of omega t minus phi. And when we draw its a graph, then it follows the steady state sinusoidal vibration. Now if we observe, its amplitude remains constant with respect to time t. Now we will write the governing equation of force damped vibration mx double dot plus cx dot plus kx is equal to Fo sin omega t. Now we have to consider the solution for particular integral. Now why to consider only the solution for xp and why not xc? Because we have seen that the amplitude of vibration for the xc diminishes with respect to time t, and the solution for xp, that is the amplitude of vibration, remains steady state sinusoidal vibration, and that's why we are going to consider the solution for xp only. So xp is equal to x sine omega t minus phi. So we have to put this value in terms of, instead of this x. So instead of x, we will put the value for xp. Now how to find out x dot p? So here also x dot p and x double dot p, that we have to put the value. So x dot p we will find out by differentiating this equation with respect to time t. Now this sine of omega t minus phi is the function of time t. So when we differentiate, it will become x dot p. Now instead of this, it will become cos of omega t minus phi multiplied by omega. So it will become x dot p is equal to x omega cos of omega t minus phi. Now we will convert this term in terms of sine, because this equation is in terms of cos. So how to convert? So for this angle, when we add here pi by 2, then this cos will convert into sine. So is equal to x omega sine of omega t minus phi plus pi by 2. Now put the value of x dot p here. Now we will move to calculate x double dot p. So again differentiate this second equation with respect to time t. So it will become, so here this cos of omega t minus phi is the function of time. So it will become minus sine of omega t minus phi. And for omega t we will take here as a omega. So this omega and this omega, it will become omega square. So x double dot p is equal to minus x omega square sine of omega t minus phi. But now we have to remove this minus sign. So when we add for this sine angle plus pi, then this minus sign will be removed. So it will become x omega square sine of omega t minus phi plus pi. So here this term we have to put instead of x double dot of p. So when we put all these terms here, then this is the, we will get this equation. Now we have to again simplify. We have to take the right hand side as a 0. So I will transfer all these terms, that is this m term, c term and this k term, to the right hand side. So when we take all these terms to the right hand side, then it will become negative. So this equation will become Fo sin omega t. So this Fo sin omega t will be external force minus mx omega square sine of omega t minus phi plus pi. So this is the mass term, that is mx double dot p. So this is the inertia force due to mass. Then here the next term is minus c x omega sine of omega t minus phi plus pi by 2. So this is the damping force, and this will become minus kx sine of omega t minus phi. So this is the spring force, and which is equal to 0. Now we have to find out the graphical solution for the force damped vibration. So we will draw here the force polygon for all these forces. this external force is at an angle of omega t. So we will draw one line which is at an angle omega t from this positive x-axis, and which is the force vector Fo. So we will show here this force vector Fo, and it inclined at an angle of omega t. Now next angle we have to find out omega t minus phi. So how to find out? So we will mark one line which is inclined at an angle phi from this Fo. So we will show here some particular angle phi, and then we will draw one line. Now this force will incline at an angle of omega t minus phi from this positive x-axis. Now we will move for the next force, that is the inertia force. So how to plot this inertia force? So if we observe the angle for inertia force, it is omega t minus phi plus pi. So plus pi, that means plus 180 degree. So when we add 180 degree, that means we have to draw one line adding 180 degree in anti-clockwise direction. Then here will be the line which will in the third quadrant. Now if we observe for this inertia force, it is negative sign. So for this negative sign we have to take this force exactly in the opposite direction. So initially this force is in the third quadrant, but because of negative sign we have to draw this in the first quadrant and in the opposite direction. So I will show here the inertia force. And inertia force is mx omega square. Now we will move to the damping force. So damping force is at an angle omega t minus phi plus pi by 2. So here we have to add 90 degree. So omega t minus phi force vector is here. So for this force we have to add 90 degree in anti-clockwise direction. So we will add here. So we will mark here one line at an angle of 90 degree, and we will draw one line. So this is the line at an angle of omega t minus phi plus pi by 2. But damping force is having negative sign. So this line is in the second quadrant, but because of the negative sign we have to take in the opposite quadrant and exactly opposite to this. So we will show this in the fourth quadrant. So I will take this line in the fourth quadrant, and this force vector is damping force, and it is Cx omega. Now we will move to the next omega t minus phi. So it is the angle of omega t minus phi. But this spring force is having minus sign. So we have to take this is exactly in the opposite direction. Why? Because of negative sign. So if when we consider only this angle omega t minus phi, then this force vector will be in the first quadrant, but because of minus sign we have to take in the opposite quadrant. So and exactly in the opposite direction. So we will show this. So this is the spring force, and it's we will show here Kx. Now we will draw the force polygon. That means we will rearrange all these forces. So first force, that is Fo, we have to draw at an angle of omega t. Now next force we will take, that is the Kx. Now it will start at the end point of Fo. So we will take here one line parallel to this Kx, and we will draw here this line. Now here is the point of intersection. Now this force vector is known as Kx. Now again from the end point of this Kx we will start the new force, that is the damping force Cx omega. Now we will take here one line parallel to this, and we will take here Cx omega. Now from the end point of the Cx omega we will start the new force again, and it is inertia force mx omega square. So direction will remain same. We have to take the parallel line. And this is the inertia force mx omega square. Now if we observe, these two lines are parallel to each other because this inertia force and spring force are at 180 degree apart. So here the angle in between this FO and KX, that is equal to angle phi. So this angle phi we have to mention here. Now I will make here one construction. I will draw one line perpendicular but passing through the origin, or we can say one line parallel to this Cx omega. So if I draw one line parallel to this Cx omega, then here is the point of intersection B. Then the value for this line is also equal to Cx omega, and direction is also in the same direction, that is towards the origin. Now how to find out? So if I mark here the point A, then how to find out the value in between A to B? So if we observe this whole vector kx, so A2 I think I will give here as a letter C, and if I give here as a letter D, then how to find out this AB? So the total vector AC minus this vector OD, then we will get here AB. So what is the value of AB? That is kx minus mx omega square. So I will write here kx minus mx omega square. So this is the value for this vector AB. Now here this is the perpendicular line. Now we will redraw this triangle ABO. The triangle ABO is the right angle triangle, and we can write FO is equal to square root of this first term square, that is kx minus mx omega square bracket square, plus the second term square, that is cx omega bracket square. Now here in each term inside the square root, x square is the common and we will take outside the square root. So when we take x square as a common term outside the square root, then it will become x. So FO is equal to x in square root k minus m omega square bracket square plus c omega bracket square. Now we will find out the value of x. So x is equal to FO divided by the square root term to the denominator. Now again we will take k square, that is under root of k square as a common term. So when we take k square as a common term outside the square root, then it will become k. So outside the square root we have to write here as a k and divided by, for the second term here no any k square, so we will divide here with k square, and here also we have to take k square. So how to simplify this? X is equal to FO divided by k under root of here k square by k square, that means it will become 1 minus. Now here m omega square by k bracket square, because here this is the separate term I have written k square, so we have to give here as a bracket square, plus c omega by k bracket square. Now again we will simplify this. So if I transfer this m to the denominator, then it will become k by m, and this k by m is equal to omega n. So how we can rewrite this? FO divided by k under root of 1 minus omega square by omega n square bracket square, plus now here instead of c by k we have to put 2 zeta by omega n. So 2 zeta omega by omega n bracket square. So this is the final formula to find out amplitude x. So instead of omega by omega n, so we can take the ratio of omega by omega n is the frequency ratio r. So how we can rewrite this? So we can rewrite this FO divided by k under root of 1 minus r square bracket square, plus now 2 zeta, and here omega by omega n, that is r, 2 zeta r bracket square. So this is the formula to find out the value of x. how to find out the phase angle phi. So we will write from this triangle tan phi is equal to Cx omega divided by Kx minus Mx omega square. Now we will simplify this. So here we will take x as a common term and it will be getting cancelled. So C omega divided by K minus M omega square. Now we will again take K as a common term from the denominator. So when we take K as a common term, then it will become 1 minus M by K omega square. So here this is the term. So C by K is equal to, we know that C by K is equal to 2 zeta by omega n. So instead of C by K we will put 2 zeta by omega n, and here omega divided by 1 minus, now this m we will transfer to the denominator. So it will become K by m. So we know that under root of K by m is equal to omega n. But K by m is equal to omega n square. So instead of K by m we will put omega n square. So here is the equation. So for this omega by omega n we will put r, that is the frequency ratio. So 2 zeta r divided by 1 minus, now omega square by omega n square, that is r square, divided by 1 minus r square. So this is the formula to find out the value phi. Now we will understand magnification factor or dynamic magnifier. We will consider one system with spring of stiffness K, damper with damping coefficient C and mass M. Now for this system we will apply two types of forces. So first one is the static force. So what is the static force? In static force, this is zero frequency, that is no any frequency. So static force Fo is applied to this system. Then the amplitude of vibration we will say xst, that is the static amplitude x to the base st. Now on the same system, if we apply the second type of force, that is the harmonic force. Now this harmonic force contains the frequency omega. So this force is Fo sin omega t. Now when we apply this harmonic force, then the amplitude of vibration is capital X. Then what is the meaning of magnification factor? So it is the ratio of amplitude due to harmonic force divided by amplitude due to static force, that is x divided by xst. Now how to find out the amplitude due to harmonic force? So we have seen the formula. So amplitude due to harmonic force is equal to Fo divided by K under root of 1 minus r square bracket square plus second bracket 2 zeta r bracket square, where r is the ratio of omega by omega n. And now amplitude due to static force is Fo by K. Now from the denominator and numerator, this Fo by K is getting cancelled and this magnification factor is having sin ohm. So we can say that this magnification factor is equal to 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square. So this is the formula to calculate magnification factor. Now how to find out the maximum magnification factor? So it is equal to 1 divided by 2 zeta under root of 1 minus zeta square, where zeta is the damping factor.